When lightning strikes a tree, it can instantly boil its water, shatter its wood, and set it on fire. And today we're going to explain exactly how that happens. There are two important things that happen inside a thundercloud that make lightning possible. First, there are lots of ice crystals and water droplets. And second, those droplets and crystals are colliding with each other. Now we know what you're thinking. Droplets and crystals don't naturally attract or repel each other. They just kind of smash into each other like bumper cars. But when they collide, they transfer electrical charges. Water tends to pick up an extra electron, becoming a negatively charged hydroxide ion, OH-. Those extra electrons make the top of the cloud positively charged and the bottom negatively charged. And that separation of charges creates an electric field between the top and the bottom of the cloud. Meanwhile, that negative charge at the bottom of the cloud pushes electrons down onto the surface of the Earth. So now you have a bunch of positively charged stuff over here and a bunch of negatively charged stuff over here. And all those opposite charges attract each other. And if they could touch, they would immediately cancel each other out. But they can't touch because nothing can pass through the cloud. There's no such thing as anti-gravity. That electric field gets stronger and stronger until it's strong enough to punch right through the insulating power of dry air. And when that happens, it makes a narrow channel of negative charge called a stepped leader. It doesn't move all the way down in one step. Instead, it steps from one little channel to another, like a ladder made of plasma. It's actually invisible until that last step when it connects with an upward streamer to complete the circuit. And that connection creates a huge surge of current that rapidly heats up the channel, and that's the flash of light we call lightning. The reason this process happens in the sky instead of under your bed is simple. Tall things like trees can generate tall streamers, while short things like you and your bed can't. So lightning often strikes the tallest object in the vicinity, unless that object is a skyscraper, in which case it'll strike that instead. But why do trees conduct electricity better than air? Well, first of all, trees are full of water, which conducts electricity much better than dry air. Plus, all that water helps maintain a constant supply of free electrons. And then there's sap, which is sugary but also electrically conductive. Finally, trees have pointed tips. And that's not just for looks. It's so the electric field will concentrate around the tip and encourage an upward streamer. So now a stepped leader has connected with a tree and sent hundreds of thousands of amps surging through its vascular system. What happens next depends on whether the tree is tall and skinny or short and stocky. In either case, the lightning bolt rapidly heats the water inside the tree to boiling temperature in a few microseconds. But in a tall, skinny tree, that water turns to steam and expands explosively, shattering the bark and peeling it away from the rest of the tree. Meanwhile, the wood fibers split apart and the tree explodes into 1,000,000 pieces. You might even see the tree burst into flames as its conductive sap carries current to its crown. A short, stocky tree will explode too, but only after its trunk splits into several large pieces. Sometimes those pieces will burst into flames, but usually the fire starts lower down. All that heat ignites the resin and sap in the base of the tree, setting it ablaze. Sometimes the entire tree bursts into flames, depending on how much resin it contains. We should warn you that standing next to a burning tree during a thunderstorm is very dangerous. That's because the branches are still charged with electricity, and they'll continue conducting current until the lightning bolt is far enough away. If you get too close, you could end up with a serious case of electric shock. If you're inside your house, though, you'll probably be safe, thanks to the fact that your walls are made of something called drywall. Drywall conducts electricity much worse than water and sap, so it won't conduct current through your home's electrical panel. In fact, drywall is so good at blocking electricity that people sometimes jokingly refer to it as the fourth electrical insulator, after air, rubber, and glass. Just don't go testing this theory yourself. Now you know how to survive a lightning strike, but what about a tornado? Find out what really happens in a tornado by clicking this video. Then watch this video or check out another great video.